right, so we've only seen one. There's two situations where we can have no solution, right, that we've seen so far. We're going to learn some other ways that we can have no solution. And it kind of makes sense because in real life, you can have situations where there's just no solution, right? Johnson, what do we do so that our small company makes $18 trillion next year? Ain't shit we can do, boss. There's no solution to that. All right, so the earliest way that we saw was something like this. Believe it or not. So when you first look at it, you can't really necessarily see that there's not going to be a solution. But if you start to work it out, you see why. So how do I work this out? Yeah, so there's nothing special you got to do. You just solve it like that equation. Bless you. Okay, what do I do next?
Combine the like terms.
Yeah.
Just remove the x from the right side.
So what do I do now? So I do what now?
Move that x from the right side.
So how do I do that?
Take
Subtract
away.
x.
Okay.
Subtract x. So I got to subtract x, and what do I get? Negative 3 equals 5. So the right way to read this, when I solve a normal little equation, so if I had this little equation, right, and you're like, please, Jeff, give me a bunch of those. The answer, when we get to the answer, we actually say, when this is true, then this is true. So sure enough, when x is 1, then x plus 1 must be 2. That's, you guys kind of with me? We don't normally say it like that, but that's really what's going on. So when this is true, then this is true. When is this true? Every other Thursday? No. Right? So this is never true. So when can that be true? Never. So what's the solution? No solution. There you go. No solution. All right. By the way, I really love your question. I love it. It's perfect. There's one way that I can get no solution. Now, if I would have gotten like 5 equals 5, when is that not true? It's always true, right? So if I get 5 equals 5, or I get any true statement, then the answer is all real numbers. Because then anything would work. It's always true, no matter what x is. All right, maybe. So another way that it could have no solution, it's a little harder to make happen. So I'm going to have to steal one from the book. Let me see if I can find one real quick. Oh, this is from like section 7.6. All right, here we go. Well, that's kind of boring, but oh well. Too bad for us. How can I make that better? I can't think of a way to do it, so we're just going to... People make the mistake of cross multiplying here. Why is that not a good idea? If you cross multiply, you're going to get like x cubed stuff. Do you really want that? Why do you not need that? Do they have the LCD already? So what can I do to both sides? Multiply by x minus 1, right? They already have the same denominator, so I can multiply both sides by x minus 1. Right, and why do I do that? Yeah, so then, because I don't want fractions, right? So it's a beautiful thing about equations is I can multiply by whatever I want to, except 0, right? If you can multiply both sides of an equation by 0, then you make everything 0 equals 0. We're still living in caves, right? It's bad. So here, the x minus 1s go away, and I'm left with what? Now be careful. How do you solve that? You could. But if you do that, very often you forget that there's 2 answers. Right? The correct thing to do is to get it equal to 0. How do you get that? And how do you factor this? Do you know what?
X minus 1.
And so my answers are, 1 and negative 1. Now, are both of those okay? Good. If you're only looking there, then you're not going to get the end. You're going to say, yeah, they look good. They look like a 1 and negative 1. It's not no solution. What can x not be? It can't be positive 1. So what do you have to throw out, of course? Positive 1. So the answer is negative 1. So that was like that was a sideways answer to your question. So this could come out with no solution if both of them make the bottom 0. But what happens more often is one or both of them are okay. The least often, but something that could happen is they could both make the bottom 0. If they were like more than, if there was an x plus 1 somewhere, then neither one of them would have been good. Does that make sense? That's another way to get no solution. This is not no solution, but one of the solutions doesn't work. And this is the place where I'm going to defend math again. What were you not allowed to multiply both sides of an equation by? 0. When we get to the end here, what's one thing that x minus 1? That's what we multiply by, right? If x was 1, what is x minus 1? 0. So math is saying, dude, you multiply by 0. And we're not allowed to do that. All right? We just didn't know we multiplied by 0 until we got there. So don't get all angry. Math is hard already, and then it gives me answers that don't work. Shit. No, it's math can't talk to us. So this is the best it can do. It's like, dude, you multiply by 0. Oh shit, let me cross it out. Yes, sir.
How come I don't know why, but I thought that when you multiply x minus 1 on both sides, you have to do the top and the bottom as well.
If you do that, you're actually multiplying by x minus 1 over x minus 1. And what is x minus 1 over x minus 1? 1.
1.
So then you're not multiplying by anything useful, right? So be really careful. If I said what's 2 times 3/4, the answer is not 6/8, right? Because then what's 6/8 reduced to? 3. Holy shit! So twice 3/4 is 3/4. So if you're making 3/4 of a dollar and you're like, all right, let me double. No, I'm making 3/4 of a dollar. Shit, wait. It's no good, right? So you guys see what I'm saying? So be careful. It's all. If I multiply by 2, it's 2 over 1. So if I multiply by it's x minus 1 over 1. Right? So it's not top and bottom. Does that make sense?
Yeah, makes sense. Yeah. Okay.
Okay. That's not what you... Well, you said x minus 1 over x minus 1.
I guess, what I meant was that, so when one of the sides are missing some kind of component, you have to multiply
Oh,
by
yeah,
the opposite.
sure.
And then
Exactly.
that's when you do the top.
You have to give it what it's missing. In this case,
exactly.
nobody was missing anything. They each had each other. Oh,
Why not?
all right. Okay. Yeah. All right. Yes, ma'am.
I have a question on the homework.
Yeah.
Okay. It's 9.3, number 9. And it says determine whether each equation has the given order pairs of solution.
Oh, yeah. Number 9, 3. Right. So tell me that ordered pair. What does a 1 mean? What does a 3 mean? X is 1. Y is 3. In fact, if they had C and D in there, for example, maybe because the next problem does, what would this be? C and D. It's alphabetical order. So if some of you guys are doing DC, you don't get to pick. It's alphabetical order unless they state otherwise. You guys kind of with me? And that was just set up because we did X, Y first, and then we said, make everything alphabetical unless they tell us otherwise. So there you go. That's exactly what they sound like. So how do I check that? Plug it in. So this is claiming that when X is 1, Y is 3. That's what that says. So when I make X 1, do I get 3? I get 2 minus 5, which is? Oh shit, is that 3? No. So is that point a solution to this equation? No. So is that point on this line? No, because those are the same thing, right? If you're on the line, you're a solution. And if you're a solution, you're on the line. So that poor little point dude is not on that line.
So you would write out no solution? Or...
It's not that there's no solution. There are an infinite number of solutions. This point is not a solution. So some of you guys wrote no solution on your in your homework, and I came in there and said, I wrote that in there. It's not a solution. Because there are solutions here, aren't there? There's billions and millions and infinite. More than a billion. There's a billion times a billion times a billion times a billion. That's still not all of them. Right? So that just happens to not be one of them.
When you plug it in, it's not a solution, right?
When you plug it in, it doesn't work.
No.
Therefore, that's not a solution. Cool. I like it. Yes, sir.
Can you do section 7.1, number 72?
Okay. That looks like it's going to be hard, and it's in the section that normally is hard stuff. But let me see. This one here, right?
Yeah.
It's got all kinds of stuff going on. What am I at? 7.1? Oh, man, so much crap in there. T plus 1, T plus 2. I think that's right. 4T4, T plus 1 cubed, man. All right, so what's the only parts that aren't the way they should be for me to start doing what I want to do here?
The cube.
That was a very vague
No,
question.
The middle part?
The middle part. That's factored already. Don't multiply that thing out. That's factored. In fact, when you have a ratio, you want things factored so then you can see what you can kill, right? The only parts of this that aren't factored are these middle terms. So what do I get when I factor this guy?
T plus 1.
Yeah, T plus 1, T plus 1. And then you got this T plus 1 from the beginning, right? So this is that middle dude. You guys with me? So this is actually easy. They already factored huge chunks of this problem for me. I don't know why they put this in the hard part. It's hard just because it's got a lot of shit in it. But the great thing is a lot of the work's done. Somebody's like, yeah. I would factor this here. T plus 2, T plus 2, and there's that T plus 2. So these three T plus 2s can do what? Yeah, you can cancel those. All, how many? There's supposed to be 3, that's my bad. All 3 of these will cancel with 3 of those. And all 3 of these cancel with those 3. So what's the answer though? 1. Something divided by itself. So it's not 0. You can never divide and get 0 unless the top was 0. And the top, I don't know what the hell it is. So the answer is 1. Everything canceled out.
I left it like that because I didn't know you could cancel for the exponent thing.
Oh yeah, so remember,
No,
T
you
plus
can
2
do that.
cubed means T plus 2 times T plus 2 times T plus 2. So those are the same thing.
So you could just, I could have just expanded.
Yeah, you could have rewritten this as T plus 2, T plus 2, T plus 2, and then each of those.
Yeah, alright.
But it's just easier to look and say I have 3 of these and 3 of them, so they just cancel.
Yeah.
Yeah.
Oh, that's awesome.
It does feel kind of nice. It looked really ugly, and we made it 1. We did good stuff.
Can I ask one more?
No. Yes. What?
92 and 7.2. Because it has division and multiplication on it. And it's good.
Man, you're going for the last ones. This is awesome.
Well, they're the hardest ones.
Yeah, supposedly. Supposedly. Let me ask you this. If I had 5 6 divided by 25 twelfths times, I don't know, Jeff. You can do it, man. Times 10 over 7. Who cares? How'd you do that?
So you multiply for whether it's reciprocal?
Multiply with the reciprocal. And now, yeah, start seeing what does. 5 goes into 25 5 times. 6 goes into 12 twice. 5 goes into 10 2. So what are you left with? 4 over 7. Alright, so now you're like, okay. But yeah, you do the same thing now with this disgusting stuff. So on this next step, this is divided by, but I'm going to go ahead and make it times, reciprocal. So now it's just, again, it's just all factoring. If you could factor, you could do this pretty well. It's just, it takes a lot of stamina just to write the problem. And I desperately hope nobody does this, because there are some of you guys I haven't seen any homework from, so I don't know if you're doing this or not. But just to put it out there, it's kind of, I'm calling some of you out. But if you cancel those y squares, that's bad. That's bad. Why is that bad? Why can't I do that?
You have to factor it first.
You got to factor. Why do I have to factor? Just because I said so? Why do I have to factor? Why? Math people, we always make everything hard. So much easier. You can kill all the y shit, and why do you make math hard? Because division does not cancel addition. It's that simple. That's all it is. I can't cancel things unless I have opposite operations. That's what opposite operations means, right? So I know it's really, we're human. We want to get rid of some of this shit. There's a lot of shit up here, right? So I want to get rid of something. You can't. Too bad. You got to factor first, right? So now if you factor. Best guy is the only nice guy. And if it's on the top and the bottom, you can cancel it. If it's both on the top or both at the bottom, you can't cancel it. Those are multiplying each other, right? All right. So I'll let you guys finish it whenever you want to. Now it's like 5 factor problems in a single problem, right? Math people like that. How many problems with the test? 5. Oh, it's really 28. Oh, this is 7-2. Number 90 something? 92. So this was division, and we multiply by the reciprocal. Now you just factor everything and then cancel. Go to town. So do you see how they put this in the hard section? This wasn't hard. This really wasn't. There's like one more thing on it than we're used to. So what? You just have another thing to factor, and you include that in what you're looking at to kill.
Would you factor the one in the middle, y squared minus y? Take the y out?
Good.
Okay.
The mistake people make here is they try to factor like that. It ain't never going to work like that. It's not squares, it's not cubes. What do you always try first? GCF. That will save your ass. You always try GCF first. Then you factor the top, you factor everything else, and you see what's common on the top and bottom. How's that? You guys doing all right?
Yep.
One of you is, all right. The rest of you, remarkably,
It looks better like that.
forlorn. That is the word, man. Forlorn. That is this class. I'm sorry. I'm a math teacher, though. I'm used to it. Bless you.
Anybody else have a question?
But on the first one too, it's not multiplication, it's division.
I know. So then what did I do? I multiplied by the
Reciprocal.
reciprocal. Yeah. It's the first thing I did, so I didn't have to rewrite the whole thing twice. Yeah. So that's the one thing to notice at the beginning of the problem, and that was the thing you said was kind of hard about that one. It had division and multiplication, but you just multiply by the reciprocal of the one that's being divided. The other one is multiplying, so you leave them alone. It's not a crazy huge deal. It looks like it's difficult. It ain't. Unless you can't factor, and then the whole damn chapter 7 is difficult, so. Right? I'm not making fun if you can't factor. I'm saying if you can't factor, you got 2 days to get it down. Because if you can't factor, you're going to fail this test. There's just I can't say it any other way. Because what's the first step in almost every problem in chapter 7? Factor. Right? All right.
Can I ask one more? Or?
Go ahead, man. It's your floor if nobody else is saying anything.
I went to tutoring for this one, and they couldn't explain me why the answer was 800. So I wrote a question mark for it. It's LCM,
Which one?
number 40 on 7.3.
All right. So here's the answer. So this is an LCM question. Somebody's asking earlier if there was any LCM questions. So what I would do with these problems is to just kind of rewrite it as if they're on the bottom of fractions. Because LCM is LCD. They're the same damn thing. So what method did I suggest to you guys to use here? What number do all 3 of those have in common as a factor? 2. They all have 2. So break them all out according to 2, because they all have 2 already. But to make it fair, you want to see, well, what else did they got? Let me give that other stuff to everybody else to make it fair. It's like the kids running around with a bowl of ice cream. He got sprinkles. I didn't get sprinkles. All right, okay, all right. All right. Good Lord, it's probably a good thing I don't have kids. So if I factor everything out according to 2, that's 2 times 4. It's amazing. 32 is?
16 times 2.
And this is 2 times
25.
25. So now you just go, okay, what's everybody missing? What's this guy missing?
16 and 25.
Well, he's not really missing a 16 though, is he?
4 and 25.
So he's definitely missing a 25. You see that? Totally missing a 25. This guy's a 16. He already has a 4. So what does he need? 4. And to tell you honestly, there's your answer already. Because you're going to make everybody look like that now, aren't you? Right? That's 16 times 2 times 25. What's he missing? 25. So that's 16 times 2 times 25. Everybody's going to end it, and he's missing a 16, right? Do you guys see that? I love that idea about just give them what they're missing. Yes, sir.
I guess where it gets confusing is that in the book, it specifically says you have to go to a prime number, and then that makes it.
I'm showing you a better way.
Well, I agree, it's the best way.
Yeah. So that's my fault. I forgot to look at what the book does, and different books do different things. I just didn't look what they did on this problem because I just go for this all the time. Breaking it down to what I call the DNA of the number. The DNA of the number is the prime numbers. It's kind of like the genes of the number. Does that kind of make sense? No. Okay, that's all right. So what I call it. That's fine, but you don't have to. What's most important is figuring out what is the number they all already have. Because that's the number you don't have to worry about. They all already have 2. Like all the kids, they already have ice cream. But that kid got sprinkles, and that kid got marshmallows, and the kid in the middle got nothing. Oh, like shit, here's some marshmallows and some sprinkles. You get some sprinkles, you get some marshmallows. Everybody's got the same thing. Okay, right? Does that make sense? Right? And you don't normally talk about ice cream and sprinkles about common denominators. But I mean, if this makes sense, do this. The book gave you the textbook way to do it, which is break that bad boy down into all its parts. But now we can be smarter about it. No, I don't need to do that. I just want to see what they already have, and then I can focus on what they don't have. That's common. So what is 4 times 25 times 2 times 4?
800.
Yeah, that's 800. Right? Good. That's where the LCM comes from. It's bad that the tutor couldn't figure that out. That
No, it's just
makes me a little concerned.
she put them as 8 equals, and then right underneath it she wrote 32 equals, and then right.
So she was doing the textbook way of
Yeah, like kind of like expanding them, but then she couldn't figure out kind of like when you circle like all the 2's, how many 2's would you put into the multiplication at last?
Oh yeah, see, that's just,
So
you don't have to
I was
go
like,
there.
Look,
Yeah.
she didn't even finish it. I mean,
I got you. Well, and again, I'm not coming down to tutors because the tutors have to be able to bounce between all these different subjects. You have to give them a little bit of a leeway. But if you see her again, show her that. Say, hey, let me show you something. Yeah.
How come you didn't you didn't multiply the 2 times 16 by the 25?
Oh, I did. There's the 25 there.
Oh,
Yeah, my bad. Just got a little mushed in there.
and what about the 4?
What for?
It's already there, 16.
Yeah.
Oh, really?
Yeah,
4 times
16 is
4
already
is
4 times 4. And that's the little thing here. If that made sense here, you're good. If it did make sense, you're going to have to do it the textbook way and really break it all the way down. But if that made sense, he already had a 4. He's got a 16. What does he still need? Another 4.
so you really need to only break it into the first
Yeah, you only have to break it
parts.
into the number they all have in common times whatever. And then that whatever piece is going to determine who's missing what. Does that make sense?
No. I mean, it
That
does,
would-
but I'm
Sorry.
not getting it for some reason.
That would only work for 2? Like if they
No,
could
no,
work
no,
for
no, no.
3 as well?
Yeah, it worked for anything. So how about this? Here we
So the answer is 800. The
You ready?
Yeah.
Yeah. Here we go. You ready? What is it, Jeff?
74.
I don't know. I want to make this come out. It doesn't matter really, does it? Sure.
33.
Let's do. Sure. Whatever. Look at you. You know where I'm going. Can anyone tell me what they have in common?
7.
LCM's 98.
And see, the other thing is, if you can't see what they have in common, that's when you fall back to the textbook method of tearing it all the way down to its prime numbers. If you can't see what they already have in common, and that's the first step on that quicker method, then you have to go back to just breaking them all down into their prime factorization, right? But if you can see they all have a 7 in them, then you can do it that way. So this will be 7 times 7. This will be 7 times 3. This is interesting.
7 times 7 times 2.
Good. That's 49 times 2, so that's 7 times 7 times 2. And I just focus on who's missing what. Right? So what's he missing that everybody else has?
3 and 2.
A 3 and a 2. Now, of course, if these are real fractions, I have to multiply the top 2, right? Right? Whatever, do the bottom, do the top. But I'm just focusing on these numbers. Is that cool? What is he missing?
2.
Yeah, he's missing another 7 because he only has 1 7, right? And a 2. So let me just go ahead and do that since I said it. And then what's he missing?
3.
3, just a 3. Cool. So what's the LCM?
Whatever that is.
Whatever that is.
29 times 98 times 3. So that's going to be 1240?
204.
294.
Oh, 294.
Yeah. What's so it's 98 times 3, right? Real quick. What's 100 times 3? 300. That's 2 less.
Oh, wow.
2 times 3 is 6. 300 minus 6 is 294. Hey. Yes.
For the test one, practice 8, number 8, the B. B for number 8.
F?
B.
B. Man, my hearing is way gone. So 8B. And the instructions say simplify. And I want to say this. I don't think I've said this exactly like this. Yeah, I think I have. Simplification. Simplify is the opposite of factor. Simplify is the opposite of factor. Because simplify means do the operation. Simplify says if they're multiplying, multiply them out. Factoring says break them back up. What was the problem before, right? So be real careful. I always have people see that and then just start try to factor things and like, well, this problem is already kind of factored. This is from AP on the practice test. Alright. So what's the unfortunate mnemonic device that's used for this? 4. But it really is just distribution. There's no need for this first, outer, inner, last business. If you really love it, you can use it. But it's actually easier just to realize you distribute that, and then you distribute that. So is that cool? That's all you have to do. When you multiply those binomials, you just have to distribute each piece. Yeah. So I don't know if it just didn't look like a normal problem. So what do you get here? 20a to the 6. Good. Not 9, right?
That's what I was going to say.
And then you get 10a cubed times negative 3x.
Negative 30.
Negative 30.
To the 4.
It's a cubed times x.
Oh, sorry.
Do you guys see that? Simple. And then you get 10
10a to the cubed x. Oh, yeah.
minus 15
X squared.
x squared. Good. And then you put your like terms together. Nothing different there. I think the problem just the way I made it just kind of made it look weird.
For 7.6.
Oh, what's up?
Of the C, the same one.
Oh, C. So the mistake people make on the problem like C is not to write it like that. I just did it without even. I didn't mean to. Shit. But the mistake people make, that's the right thing to do. The mistake people make is they go, okay, that's 9 plus 25y squared. Yay. And of course that's ground. Because if you say that on your paper, I'm going to write, so 5 plus 2 squared equals 25 plus 4 equals 29. But what's 5 plus 2? And what's 7 squared?
40.
Not 29, right? So that can't be true. Right? You can't square across a subtraction. Squaring is based on what operation? Squaring is based on what operation? Exponents are based on multiplication. So if I add like 5xy squared, this will totally distribute all day long because the only operation inside is multiplication. Subtraction, it doesn't play well with subtraction. It's not based on subtraction. But like a coefficient, what are coefficients based on? Addition, believe it or not. What does 2x mean? Don't say 2 times x. What does 2x mean? X plus x. So that's why this can go across subtraction. Because they're based on addition, subtraction kind of stuff, right? That's why it's easy to have a coefficient. When you have a square, shit, I need a way around that. And what's the way around it is to do what squaring something means. Squaring something means that thing times itself. And now you can FOIL that bad boy, right? So then it becomes just like number 8b. Then you just FOIL it, distribute the pieces. Is that cool? Some of you guys look like you really want to hurt me. It makes me scared about walking out the door. Yeah.
Practice test 1 delta.
But like number D is already factored. Sorry.
Oh, but 8D?
No, yeah, 8D is already factored.
But the instructions don't say factor. The instructions say...
I know, but just know you said they are opposite. So just put them together. Put them back.
Yeah, multiply them out. Yeah. So don't tell me they're already factored. It's like me saying, what's 2 times 3? And you say, well, they're already factored. No. What's 2 times 3? Do the multiplication, right? So yeah, that is factored, but the problem says simplify, which means actually do the operation. Good.
Well, I'm just using, can you leave it, for example, when you distribute that, you can just leave it like a 9 minus 30y, whatever, right? You want it to like put the y squared forward.
Oh, this is fine. You don't have to put it in descending order. Yeah. So anything else about that one before I go over here? So which one?
1 delta on the practice test.
Oh yeah. This is one of her favorites. All right.
So-
What piece of this do we do
It's
last?
P to the 5th.
Is it? Oh yeah, I left the 5. Oh yeah, thank you. What piece of this do I do last?
It's outside.
Yeah, good. Order operations kind of saves us there. So my colleagues teach to bring that in first, and to me that's just disgusting. I mean, 12 to the negative. No, screw that shit. And if you like doing that, go ahead. You're weird to me, but it's still not wrong. It's not wrong, but to me, order operations, just keep following order operations. The less crap I got to do that to, the better, I consider, I think. Right? It's not wrong to do that way. So what's your suggestion?
So 4 of 11 right out the back.
Beautiful. So the first thing you do is just simplify the numbers. They're just numbers. You reduce them like you always would. 3 goes into both. Kick ass.
Now, would I bring the M to the bottom? Or
Beautiful. Which M wants to move?
Negative 4.
Yeah, these 4 M's are negative, so that tells you they don't like it up there. They want to go down there. Do these go up?
No.
Why would they? They're fine. They're fine. Right? Only the negative powers move.
So it's up to the 7.
And these 12 doesn't come down. It's not connected to that like that. So it'll be, yeah, and let me go ahead and write it out. So those 4 M's come down. What happens with the P's?
You subtract.
cancel?
Yeah, 1 P cancels, so you're left with
P to the 4th.
4. So the last thing I could do on the inside, like Harvey said,
Up to the 7.
yeah, there's 3, 4, so there's 7 total down there. All right, how are we doing so far? All right. So I understand we sometimes have a brain fart. You might put a 12 down there, right? You can see why somebody might think that's a 12. Because your brain is like, multiply, multiply. You got to be, dude, you add powers here, right? Just if you start doing it all over the place, you get concerned. Right? And what 2 things does this tell me to do now?
Multiply.
No, what's that negative mean? Do what to this?
To the bottom.
What's a negative power mean?
Reciprocal.
Flip. So what am I flipping? This. Because what is the negative power sitting on? This. So then I just flip it.
So 11. Alright, so
And what's out here now? 2, because I already did the negative part. I did what it wanted me to, so it's gone. And so I still have 2, and then I will be done. All right, cool. You were finishing all my...
Second.
All right.
21, 14, 16, 8.
Yeah, exactly. Because you multiply powers when you raise something with a power to a power. All right. Let me stop there for a second. How are we doing?
You know, I thought it would be like M49.
Totally not. Let me ask you a really weird question. Is there a 7 in there?
No.
There's no 7 in there, so there can't be a 49 coming out of there. Because there's no 7 in there. If there was a 7 here and I squared it, I would get 49. What am I squaring? 11. Okay, that's 121. I'm squaring M7. So that's M7 times M7, so how many M's now? 14.
Oh.
2 groups of 7 M's, 14 M's.
Isn't that the final answer?
Yeah, totally.
Uh,
How are we doing, Zach? Easy. All right. Yes, sir?
Can you do an example of interval notation?
Interval notation, okay. So, we haven't seen absolute value stuff yet, but we have seen stuff like this here. Just straight up like this. Alright. How would you solve that? Interval notation and graph it.
Subtract 5. I mean, add 3. Add 3.
Sure, okay. Add 3
And subtract me.
and subtract 6x, okay. So you get,
Negative 2x. Great. No.
yeah, because have you divided or multiplied by negative? No. We just added subtracted stuff. So that's the same.
That's 8.
And of course, I did this on purpose. All right. What do you have to do now?
Divide by negative 2.
Divide by negative 2, and then what happens?
The sign's flip.
Yeah, the sign has to flip. Right? Why?
Because it wouldn't be true if you left it.
I like it. I like what we say. Yeah, it wouldn't be true otherwise. You know, well, why the hell is that? Because we did this whole thing here, didn't we? Which one's bigger?
1.
1. But if I divide by negative 1, now I get negative 1, and I get 2. Which one's bigger now?
2.
And that sign flipped. All right. So the answer is because it does. I like that. It wouldn't be true otherwise. I love it. So how do I graph this?
Negative 4.
Plop a negative 4 in there. What symbol do I use?
Dot shaded it.
No.
Bracket.
Bracket. And which way am I going to shade?
Left.
Yeah, so you open the bracket that way, you're going to shade, and you shade. All right, so no more circles. No more. And then how do I write that interval notation, which you're finally getting to the question.
Infinity, comma, negative 4.
Yeah, you always do from smallest, comma, biggest. All right, so I see a few too many people doing it the other way around. It's just not anything you want. It's from smallest to biggest. So what's the smallest?
Infinity,
Negative infinity.
negative.
And the biggest. And use the same symbol there. When does this become a bracket on the infinity?
Never.
Never. I love it.
Wait, why is that infinity?
Is there a floor to this? Where does it stop?
Never.
It goes forever. And that's what infinity means. Infinity is not a number. Infinity is a process. Take 1, add 1 to it. Keep doing that forever. That's infinity, right? So this is take negative 1, subtract 1 from it. Keep doing that forever. That's negative infinity, right? So if you think you've made it to infinity, add 1. So you can never get there. It's not a number. And that's why we don't put a bracket on it, because you can't get there.
Something wrong with the camera.
Uh-huh.
It says something about batteries.
Well, that's probably what's wrong. Well, that's your problem, Jeff. All right. I forgot to bring my spare battery. We'll see how much I can get out of it. Good thing y'all here. All right. Yes, ma'am.
Homework 7.1, number 45.
All right. So this has got 2 of our second favorite factoring forms. Of course, our favorite form is cubes. Our second favorite is when the first number is on a 1. Let me show you a neat little trick on the top. What's special about the first and last number on the top one? What's special about 4 and 9? What's special about 4 and 9? And 16 and 25 and 36 and 49 and 81 and 120. They're squares, right? So sometimes when the first and last number are squares, that would be 2 and 3, right? Right? So something you can always try is just try 2x3, 2x3. How do you make negative 12 in the middle? Minus minus. Do you get negative 6 and negative 6? It's negative 12. Top is done. Yay. Now if you forget that method, you'll do what we're going to do to the bottom here. You can still do 4 times 9 is 36. What fraction of 36 make negative 12? Negative 6, right? And then you break up the middle term, you eventually get there. You can still do that, nothing wrong. So let's do that to the bottom, because the bottom doesn't work that same way. They're not squares, so I can't try that. Right? There's just a little special trick you can try if they're squares. It might not work, and then you just do this. So what do you get here?
Negative 60.
Negative 60. So we need factors of that that make negative 11. So remember 15 and 4. And which one's negative?
Negative 15.
Good, negative 15. How you guys doing?
Good.
You're like about the same as you last time you answered. So if you break this, let me look at this by itself here. Break up that middle term. Break it up using these numbers, right?
Negative 15x.
Good.
It's 4 and 6.
And of course, the whole reason we do that is because now I can group. I love it. Grouping is one of the easier forms, right? Look at there.
5x. It's 2x minus 3.
2. And what tells you you're on the right track?
Because you have 2 of the same.
These are the same. If they weren't the same, go back and try again. Someone wrong. So then what's the answer for the bottom?
2x minus 3. And then 5x plus 2.
Alright, so let's go back up here. So now we got 2x minus 3, 5x
Plus 2 is
two.
your answer.
And of course, what happens?
Cancel.
Yeah.
So 2x minus 3.
That's the answer. Oh, hold on. Let me go ahead and give you guys the answer key for more students. You want the answer key? No? Okay. She got his name. Mr. Overconfident. That would be a mistaken answer. Hey man, that's fine. You don't have to take this if you don't want to. Anybody else not want this? No? Alright, you won't get one. That's the weirdest thing that just happened. It's weird.
It's not happened before.
No. I'll give you a choice. That's good. I don't even know how to react to that. If you read it, you're right. So let me say this before I forget. I don't think I can't remember if I said this already, but maybe only do these problems. Oh, do you? Oh. Are you good? You got it? Okay. Only do these problems maybe twice at most. Because if you do it more, you're getting to know that problem. You're not getting to know how to do that kind of problem. Because I ain't going to give you these problems on the test. All right. And also, don't do this. Don't do this. Oh, yeah. Yeah. I would have done that. That's what I would have done. Because that's not doing you any good, right? So what I would do, if you don't have to do this at all. You don't have to do this at all. The homework is good practice for the test. You can do this and then see what you got wrong and then go focus on that section. Right? That's one way to kind of do this. You can just look at it for the form and the kind of questions I might ask. Right? You kind of with me? All right. Yes?
Page 490, number 30.
Number 30? 30 changes my life. All right. Let's see. Citation CV Jet. This is number 30 on page 490, section 7.7, the last section. travels. So we have distance rate time problem. So we can do this if you want to. It's not a bad idea. What's the formula for distance rate time? Yeah, because it's dirt, D-E-R-T, D equals R-T. You don't have to do this chart if you don't want to. It's just a nice organization. There's a lot of information. So it tells me that a Citation CV jet travels 460 miles an hour in still air and flies 525 miles into the wind and 525 miles with the wind, blah, blah, blah. Oh my God. So we have two things. We have with the wind. We're doing the same order that into the wind.